Hi madam, we are a student from DPE3C and today we are going to talk about Safety Interlock System SIS in Petrochemical industry. So before I start our presentation, I would like to introduce my group member, which is myself, Rachel Samuel. Second, we have Lorena Najimi. Third, we have Nushafika binti Anis. And last but not least, we have Trinity Rita Anantoni. So in this slide, I'm going to talk about the introduction of SIS. So what is SIS? SIS is a collection of SIF designated to bring an industrial process to a safe condition in the event of multiple dangerous detected condition. SIF is one or more component designated to execute a specific safety-related task in the event of specific dangerous condition. This time, I'm going to talk about the plan process, which is the operating condition of the box interlock. One PSV, or as known as PSVA, is operational, and other, which is PSV, which is PSVP, is standby key B, is taken from the control room. So, insert key B into valve 4 and close by releasing key A. Key A can be taken to the control room to keep PSV isolated for maintenance.
To change over the putting PSVA into the operation and PSVB into operation, insert the key B into the valve state 1, open by releasing key C, both the safe type are online. Insert key C into the valve state 2 and close by releasing key D, which can be taken to the control room. PSVB is now in operation and PSVA is in a standby. To further isolate PSVA for maintenance, insert a key D into the valve state 3 and close releasing key E. Key E can be taken to the control room to keep PSVA isolated for the maintenance. Both PSV will never be closed simultaneously, ensuring that at least one PSV is always available for equipment protection.
In order to provide a risk reduction factor of a greater than 10 times, it cannot be interlinked with the basic process control system and specialized 100 PLC like a device that may have a multiple processor executing the logic in parallel to ensure integrity of the logic and resulting action. The SIS is designed around individual function in the plant called a safety intercepted function, or SIF for a short. The logic solver takes the SIS inputs and determines what the state of the SIS output should be for that SIF. Consider the process above for the transferring a liquid from a tank to reactor. Normally, the flow controller, which resides in the basic process control system, can easily make the transfer of a liquid in a very controlled, repeatable manner. When the reactor level reaches a high alarm point, the flow is stopped by shutting the control valve in order to keep the closed tank from overpressurizing. In order to safely transfer the power source from a generator and back to main, a safety interlock system is often employed. The interlock consists of one or more switches that prevent with the manpower and the generating power from powering the all-in simultaneously.
Type of safety interlock system. Number 1 is rotary hinge safety interlock. It is designed to mount the hinge side to access door. These devices have no slot or nest where dirt or other materials can collect and cause problems, and because they are usually mounted out of the way in the machine frame, they are less likely to be exposed to airborne dirt, oil, and mist or tampering. Number 2, standard mechanical safety interlocks. The safety interlocking housing ends a separate corded actuator. The actuator is usually mounted on the gate and aligned to a slot in the housing, which is mounted on the structure. Number 3, guard locking safety interlock. Have a separate actuator and use solenoid system to lock the engaged actuator in place. The solenoid not only monitors the gate for open and close position, but also hold the gate closed, preventing access to main machine until it verified that the machine is safe state. There are two most common guard locking interlock, which is spring locking and power locking.
4. Magnetic safety interlock. A magnetic safety interlock has a sensor and magnetically coded actuator within the sensor are multiple magnetically actuated with contacts that match up with a specifically coded actuator in order for the machine to run. This magnetic coding is not only redundant in design but also defends against bypass using a simple magnet. Example of safety interlock system. Safety instrument systems are most often used in processes such as refineries, chemical, nuclear, in facilities such as high fuel gas pressure initiates action to cross the main fuel gas value. Second, high reactor temperature initiates action to open cooling media valve. Third, high distillation column pressure initiates action to open a pressure vent valve. And the thermocouple on a gas stove prevents the release of unburned gas if there is no ignition of the gas. A light curtain, a capture lever device, and thermocouple are examples of an interlock sensor and actuator.
So for conclusion, safety is an important part of any industry, especially in hazardous industry such as oil and gas and chemical industry. Safety interlock system is vital in industry. In word of safety, it is something that prevents possible damage or death to people operating the process equipment.